Hello and welcome back to this channel. Dear students, today's topic is FM radio broadcasting. We'll discuss the transmitter as well as receiver block diagram in detail. We'll also discuss the features, then advantages and limitations of this FM radio broadcasting system. Then we will compare AM and FM. Now, this is the block diagram of FM radio broadcasting. The upper portion is the block diagram of transmitter session. The major blocks are audio amplifier, then FM modulator and RF power amplifier. Basically, this type of system is used for the transmission of audio signals using frequency modulation technique, and it is line of sight propagation. Now let us discuss the block diagram in detail. As I said, the upper portion is the block schematic related to the transmitter session. So first block is the audio source. We discussed that this is the system which is used to transmit the audio signal. So audio source can be a microphone, it can be a music player, or it can be a recorded system, anything that generates the audio signal. So this audio source generates the audio signal which is applied to the audio amplifier. As the name indicates, the strength of this audio source is less, so to improve it, audio amplifier is used. So the major functions of this audio amplifier, I have listed some points. So the major functions of this audio amplifier are: the modulation quality is increased. This upward arrow indicates the quantity is increasing. Then transmission efficiency is increased, as well as the distortions are reduced. So this is the major function of this block, audio amplifier. As I said, as the name indicates, this is an amplifier which accepts weak audio signals and amplifies it for the further processing. Next block is FM modulator. This is frequency modulation technique. That means according to the amplitude of the incoming signal, the frequency of the carrier wave is changed. The amplitude of the carrier wave remains same because it is a frequency modulation. So according to the incoming signal, the frequency of this carrier wave is changed. This is the FM modulator. Next block is RF power amplifier. As the name indicates, it is used to boost the power of incoming signal. So the major functions of this block, RF power amplifiers, are: it provides better signal coverage. Then it is basically used for long distance transmission and improves the broadcasting range. So these are the functions of this RF power amplifier. Next block, last block of this transmitter side is antenna. We know that the major function of antenna in this case is to accept the incoming electric signal. See, the incoming original signal is an audio signal. It is converted into electrical signal. Then it is applied to the antenna. The function of antenna is to accept electrical signal and convert it into EM, that is electromagnetic waves, because we need to transmit this signal through the free space. So the function of antenna is to accept electric signal and convert it into EM waves. So these EM waves are transmitted by this transmitting antenna. Now, the major important part is the height of transmitting antenna is the major parameter which decides for how much range we want to transmit the signal. No doubt, if there are certain obstacles, then it affects the communication range. Then these incoming these EM waves, that is electromagnetic waves, travels through the free space, and at the receiver side, this lower part is the block diagram of receiver side. At the receiver side, the receiving antenna captures these signals, accepts this electromagnetic waves and convert back into electric signal. Then it is applied to the RF amplifier to amplify the power of the incoming signal and to improve the sensitivity of the system. Then its output is given to the FM detector. This is the demodulator. So the function of FM detector is to extract the audio signal. So this block extracts the audio signal, then it is applied to the audio amplifier. Like the audio amplifier of the transmitting session, this part, audio amplifier, is used to boost, to improve the signal strength. So audio amplifier improves the signal strength and output of audio amplifier is given to the speaker. So speaker again produces the audio signal, because originally transmitted signal was not electrical signal, it was a sound, it was a audio signal. So the function of this speaker is to again reproduce the audio signal. So this is the generalized working of transmitter and receiver session of this FM radio broadcasting. Now some important mathematical expressions. The output of FM modulator is given by the equation Fi of t. Fi of t is the instantaneous frequency, is equals to Fc. Fc is the carrier frequency. Kf is the parameter related to the sensitivity. M of t is the message signal. Now the bandwidth of this system is given by, this is given according to the Carson's formula. So bandwidth is 2 delta f. Delta f is frequency deviation plus fm. Fm is the modulating frequency. So this is the generalized working of FM radio broadcasting system. Now let us discuss the features, advantages, limitations and applications of this FM radio broadcasting. So important features are it has better noise immunity. Then this system is usually preferred whenever it is required to have high quality audio transmission. Then there are minimal interference, that means it reduces the interference. Then constant amplitude transmission is performed, because we are using FM modulator, so FM modulation technique, so the frequency changed but the amplitude remains constant. So these are important features of this system. Then advantages, as we discussed, it provides better sound quality, then there is a minimal effect of noise, and it provides high S by N ratio. S by N stands for signal to noise ratio, and reduced distortions. There are of course certain limitations. The major limitation of this system is that it needs larger bandwidth. Then the design is complex, especially the receiver parts designing is complex, and LOS, that is line of sight communication, is always required. So these are few limitations of this system. Then applications, we know the major application is FM radios, so commercial radio stations, then public information systems to make some announcements and all that, then traffic information to provide the updates of the traffic, then local communication services. Now let us discuss the comparison between FM and AM. FM is the frequency modulation, AM is the amplitude modulation. We discussed the FM radio broadcasting system. Now let us compare these two things. We'll discuss it parameter wise. First parameter is modulating parameter. As the name indicates, in case of amplitude modulation, the modulating parameter is amplitude, and in this case it is the frequency. That means in FM, as we discussed earlier, the frequency changing as per the change in the message signal, whereas amplitude remains constant. Then sound quality in AM is moderate, whereas we are getting high sound quality in case of FM. Noise immunity is low in AM, and we are getting better noise immunity in case of FM. Bandwidth requirement for AM is less, whereas bandwidth requirement of FM is more. Then interference is more in case of AM, and it is less in case of FM modulator. So this is the comparison between AM and FM. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.